Why, some say the moon. Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win, and the others too.
While our sights are once again set on our lunar neighbor, this time we're not content with just leaving behind footprints, or even to leave it all. This time, the time has come, we really believe, for the United States of America to take what we have learned over these so many decades, put your ingenuity and creativity to work, and establish a permanent presence around and on the moon.
We live in an era of renaissance of the space program. As Apollo did in the 60s, the Artemis program now promises to land humans on the moon in this decade. The Apollo program, which was incentivized by the space race against the Soviet Union, was a goal-oriented mission. The only criteria for whether something was to be done was whether or not it was useful for achieving the goal. Unfortunately, the Artemis program isn't designed in the same manner. As politically incorrect as this might be to say, the Artemis program is designed to give as much money in the form of contracts to its suppliers, as well as to save face for some projects that should have been abandoned long ago. It's a jobs program, keeping thousands of brilliant scientists, managers and engineers working on it for years just for the sake of doing something, whether or not it is a good solution. The program involves the extremely expensive SLS rocket and Orion capsule, as well as building a space station in a halo orbit around the moon that only serves to justify Orion's incapacity to reach low moon orbit and return to Earth. It also involves a modified version of Starship, which would take the crew from the Gateway station to the lunar surface and back. NASA also wants to select and fund the development of a second lunar lander for future missions.
Now, this here is the mission architecture that has been published for how to do a moon mission using the Gateway. Okay? It requires 4 launches for every mission. It requires 5 flight elements. It requires 6 rendezvous for each mission. That compares to Apollo, which was 1 launch, 1 rendezvous, 3 flight elements. Okay? So people say Apollo wasn't a sustainable way to go to the moon. Apollo was a far more sustainable way to go to the moon than what is being currently proposed. This is absurd, okay? And multiplying all these dependencies, 15 different things in this mission, which if any one of them goes wrong, you lose the whole mission. This is totally absurd. It is completely irresponsible. You know, this is like adding extra parts to Macbeth so to give every kid in the class a part in the school play. Okay, that's what it is, and that's fine for the school play. But this is not how you want to do a space mission. You want to make it as simple as possible.
This is all unnecessarily complex and expensive, and thus likely to be delayed or even fail altogether. It is for this reason that I hereby present MoonDirect 3. MoonDirect 3 is an architecture for affordable crewed lunar missions, with hardware and approaches derived from MassDirect 3. For the sake of clarity, MoonDirect 3 is not as specific as MassDirect 3. If one was to design a lunar mission from scratch, one would probably want a smaller lunar lander than the Caravel, and which uses hydrogen and oxygen as fuel, especially when refueling from the ice on the lunar poles becomes possible. I'm going to be referring to the lander as Lunar Caravel, assuming that the same vehicle used for MassDirect 3 is adapted for lunar missions. However, you can replace it for a number of other lunar lander options in that mass range or smaller. The spirit of Moon Direct is that, whether you use the SLS, Falcon Heavy, Starship, or whatever the best that you have at the moment is, just have a rational architecture guiding the program. Moon Direct 3 is that plus the big ship small ship strategy explained in Mars Direct 3. That is, yes, using a small lunar lander like proposed in other Moon Direct concepts, but also taking advantage of the capabilities allowed by using the lunar Starship as a one-way cargo lander. This architecture eliminates the need for SLS, the Orion capsule and the Gateway station. The first change is to modify the lunar Starship. In its current configuration, it is a huge pressurized vehicle that is projected to take only 2 astronauts to the Moon, by NASA. That ship is unnecessarily big for 2 astronauts. Given that it's very hard to produce fuel on the Moon, in order to be able to return, the lunar Starship offers little payload capacity. And, in case oxygen production for fuel became available in the future on the Moon, around 115 tons of oxygen would need to be produced for each flight of the Starship back to Earth. Instead, as in the case of Mars Direct 3, Moon Direct 3 calls for the development of a smaller lunar lander. This would be the same as the Caravel ship, but without the heat shield or the secondary fuel tanks. We assume the lunar Caravel ship to have a dry mass of 28.5 tons. It would launch inside of a Starship's cargo bay, loaded with 95.7 tons of methane and oxygen fuel. The Starship would reach low Earth orbit. There, it would rendezvous with a previously launched tanker, which has already been refueled by 2 other tankers. After the fuel transfer, the tanker lands back on Earth. With this extra fuel, the Starship burns 3.25 km per second of delta V, completing the translunar injection burn. At this stage, the lunar Caravel would separate from the Starship. The lunar Caravel would burn 650 meters per second of delta V to get into low lunar orbit, while the Starship would maneuver in time so as to get a free return trajectory from the Moon, aerobraking and landing on Earth a few days later. Then, the Caravel would spend 1.8 km per second of delta V to land on the surface of the Moon. For the return, the Caravel burns another 1.8 km per second of delta V to get into low lunar orbit, and then a further kilometer per second to get into a highly elliptical orbit around the Earth. These are very conservative estimations for the amount of delta V that each process would take, and 100 meters per second are remaining as a security bonus. Once in this elliptical orbit, just like in Mars Direct 3, a Starship could be launched to rendezvous with it, and then landed. In both cases, if this process wasn't trustworthy enough, the Starship could carry a Crew Dragon capsule so that the astronauts could land separately. Using a smaller ship to ferry the little amount of astronauts that NASA is planning to take to the Moon makes a lot more sense, and the Caravel could actually transport many more than 2. Each crew-rated ship would also be a lot cheaper. The lunar Starship would become an unpressurized cargo vehicle, which would land more than 100 tons of cargo to the surface of the Moon per flight, and stay there to serve as materials or part of a base. Assuming 7 tankers per Starship to the Moon, and 3 tankers per Caravel to the Moon, a 2-ship 100-ton crewed mission to the Moon could be carried out with just 13 launches. It may seem like a lot of launches compared to NASA's architecture, but Starship launches are reusable and thus a lot cheaper, estimated at less than $5 million per tanker mission. And NASA's architecture already requires around 8 Starship launches to deliver the lunar Starship to lunar orbit. And well, for each launch of the SLS plus Orion, which is around $4.5 billion apiece, you could launch almost 100 Starship tankers even if they cost 10 times what is estimated. 13 Starship launches is a lot better than 8 Starship launches, plus one SLS launch, plus the proportional cost of building and operating the Lunar Gateway Station. Additionally, Moon Direct 3 accounts for more than 100 tons of cargo delivered to the surface of the Moon, not counting the Starship itself. This is an insane amount compared to all the mission profiles. Artemis only contemplates the Starship delivering a few tons of cargo. The only downside is that the astronauts would spend longer en route back to Earth, given that they might have to complete a few long elliptical orbits before a Starship rendezvouses with it and lands it. But given that NASA plans on the astronauts staying for a month in the Gateway Station, which is even smaller than the interior of the Caravel ship, even if this problem wasn't solved, I sincerely believe this to be just better.
There are more ways to do a Moon Direct 3 kind of mission. The key is realizing how much of a game changer the Starship vehicle is. It's a huge ship with a huge payload capacity that will be reusable and cheap. It takes a few launches to get it to the lunar surface, yes, but they're cheap, reusable tankers, and the result can be 100 tons of cargo on the lunar surface. That is more than any previous mission has ever dreamed of, and would be enough to build a base just by itself. For instance, instead of the Caravel carrying enough fuel to go back to Earth, you could have the Starship do it. This is, again, around 40 tons of fuel, so around 40% of the cargo capacity of Starship. And this time, it's for both the methane and the oxygen. Another option would be to have a Starship fuel depot in low lunar orbit, which would be able to support many missions at a very small price. The Starship system has the capacity to bring many wonders to the space program, if used right. This mission also doesn't use rockets or ships made by other companies rather than SpaceX, which would stop NASA from handing out money to many contractors. Unfortunately, the decision is more political than practical. Some higher-ups refuse to deal with the fact that, as soon as the Starship launches a few times and proves to be safe, the SLS will be made completely obsolete. But if you keep spending money just for the sake of it, you'll have no money left for real missions and exploration. No money for expanding a base. It's just a waste that dooms the space program to stagnation or even cancellation. I love NASA, and this is mostly not their fault. They are brilliant people, and most of them are aware of the problems of their vision. They are a branch of the US government, and thus their hands are mostly tied by Congress, the Senate, and the various lobbies that pressure them. I live in Spain, where some regions have had unemployment rates ranging from 20 to 30% for decades. This is insanely high. In the US, unemployment is now at 3.5%, which is basically full employment. Companies are desperately trying to find more qualified workers to fill their ranks. However, for reasons that I'll leave to your imagination, many politicians prefer maintaining a few useless jobs rather than having a functional space program. I'm not making this up. It isn't the first time that something like this has happened. The Constellation program was cancelled, and so was a mission to an asteroid that was supposedly going to be deviated into lunar orbit. This idea, which was deemed impossible, justified paying for the development of the SLS and Orion for a long time. Artemis and the Gateway are just the new justifications for keeping these programs alive.
The key thing I want to point out is this, that in any solution you want, you've got an engineering possibility. These are the things that can be done engineering-wise. And as close to the center, that might be where you want to be with the perfect engineering solution. And I think Bob is going to take you to the perfect engineering solution. He's going to explain why it's perfect from an engineering standpoint. Then you got the things that you can afford and you can do economically. And there's some overlap in that Venn diagram, and you want to be, as close to the center of that as possible. And then there are the things you can do politically. And whether you like it or not, if you go and you try to kill off the program of record and stop Artemis and start over with the Moon Direct program, instead of doing it in parallel, you're going to create the antibodies from Alabama and elsewhere, and they're going to come out, and they are going to shut down human spaceflight forever. I would not be surprised to see the next president come in and simply kill human spaceflight forever because the space community is too busy having these debates and arguing with each other over the zero-sum game. They don't like fighting.
I conceive of two scenarios where they would change their minds towards a goal-oriented mission architecture such as this one or some other idea. Either a new administration comes in and sees reality for what it is, which might happen if the Starship is successful, or a space race with China makes it clear that the goal is to settle the moon, not spend money while pretending to do so. And just before the end, I'd like to refute what I believe is the strongest argument in favor of government space missions that are vendor-driven. This point was made by Greg Autry in a debate he had on the topic with Robert Subrin. He basically said, okay, maybe some of these missions are not that useful in and of themselves, but they allow us to fund the space sector so that they can develop the capabilities. For instance, if we hadn't built the ISS and we hadn't given contracts to SpaceX, they wouldn't exist today. And that's true. Had they not received the NASA contract in 2008, SpaceX would have likely gone bankrupt. However, first there's the point made by Subrin in response, which is, you can also give contracts to SpaceX and other contractors to do missions that are actually rational and useful. And second, I'd add to that those contracts aren't the only reason why SpaceX exists. SpaceX also exists because Elon Musk was so disappointed at NASA's Mars plans that he eventually decided to do it himself. Does that justify having bad programs so that private people are so disappointed with their government that they decide to do it themselves? And another reason why SpaceX exists is because, a few years before creating the company, Elon Musk joined the Mars Society and read The Case for Mars by Dr. Robert Subrin. He read about how to actually do these missions, and do them cheap and do them well. That's a mentality that was lost in NASA 40 years ago when the shuttle failed to deliver on these promises, and it's the mentality that we need to go back to the moon, Mars and beyond.
In any case, this is it for Moon Direct 3. I hope that you liked the video. Hopefully one day a goal-oriented space program will lead the way. If you enjoyed the video and you haven't watched the video on Mars Direct 3 yet, I highly encourage you to do so. Moon Direct 3 is just one more application of what's explained there, and is a much better and detailed video than this one, which was a little extra. Thank you very much for watching and have a nice day.